in tech, if you're standing still, you're moving backwards because complexity is always conspiring to overtake you. And, there's always more and, exceptions. Like you have to be actively fighting against that in order to just keep up.
Machines are so fast and stores are so big that they give us plenty of latitude to screw things up.
The shell, which is the name we give to the command interpreter.
So the operator got a pair of tweezers and very carefully fished the moth out of the relay.
Because you all read the Mythical Man Month.
And the best motivator in the world for programming is scratching your own itch.
Developers.
Hello and welcome to the Sourcecraft Podcast, a show where we chat about developer tools with their creators. Today I'm talking with Charity Majors, founder and CTO of Honeycomb, a tool that helps you understand the state of production by combining logs, traces, metrics, and more into a single high-cardinality data blob that you can explore in just one place. We talk about observability and how it's different from metrics and monitoring, war stories from Charity's time at Facebook and Parse, and how dev tools can make programming more accessible to everyone. If you care about bridging the gap between dev and ops and getting faster, better feedback on how your code runs in production, stay tuned. All right, I'm here with Charity Majors, former engineer at Facebook and Parse, now co-founder and CTO of Honeycomb, and I believe the person who first coined the term observability as it relates to DevOps and modern application development. Charity, welcome to the show.
Thanks for having me. I think that I was the person to give observability a specific technical meaning. People have been using observability to refer to generic telemetry. And of course, there's the long and storied history of observability as a mathematical dual for controllability. But I think that we at Honeycomb were the first people to sit down and go, okay, this is about the unknown unknowns. And if you accept that definition, then what else proceeds from there? So we'll accept that part.
Thank you for the clarification. And I think we have a lot to talk about today.
Oh, yes.
I want to dive into observability and Honeycomb and your thoughts on a lot of different things. But before we get into that, we like to kick things off just by asking people, to tell us a bit about their backstories. How did you get into programming and engineering, and what's been kind of your, brief life story as an engineer that's brought you to this point?
Oh, I have a weird and wandering road. I was homeschooled in the backwoods of Idaho, and I went to college on a performance piano scholarship when I was 15. And it was really just like get me out of here. Oh my God, I haven't seen another human being in 6 months, and I'm going insane. But I got to college and discovered computers there because I noticed pretty quickly that all of the music majors were poor, and I was very tired of being poor. So I swapped keyboards, and I've just kind of been tinkering ever since. And I love that. I really love that there are so many people with non-traditional backgrounds in engineering, and it makes me a little sad that I feel like the doors are closing a little bit, that there are these certifications and these qualifications and stuff that, when I got started, it was really just like everyone was so desperate. If you could if you knew how to launch Emacs, like you were hired.
Yeah.
So, professionalization is a good thing, but there aren't many growth industries in the entire world, I guess.
Yeah.
Through my lifetime, and computers has been that. It's been a real source of opportunity for weirdos.
Yeah, definitely. And I think, at least in my experience, I found a fairly weak correlation between official certifications and, even degrees and skills.
Oh, no, totally. It's not about being able to do the work. It's about cover your ass, like as a hiring manager. Totally.
Yeah. Well, I certainly hope that
I feel like we could rant about this for a long time.
this is like a whole other podcast.
Oh boy.
Yeah, definitely. I'm actually just a little bit curious about you said, your original, I guess, academic pursuit was piano performance. Are there any favorite pieces or songs that you still like from back in the day?
I love Rachmaninoff. I really love the Romance composers. So I did music, and then I did Latin and Greek, And
Mm-hmm.
then I did electrical engineering. And then I got a job as a sysadmin for the math stat department. This is back when they were still giving kids root on campus, which was a terrible idea. What were they thinking?
So much power.
Oh my God. And then I had root for the entire campus and I kind of slowly stopped doing schoolwork and started working more and more.
Yeah.
And then I got offered a job in Silicon Valley for like $75,000 and I had never heard of anyone making that much money. And I was just like, done. I'll, I will go. I will go do that. And I've been down here ever since. But I feel like I've been really lucky in my career. I've worked with some amazing people that, it's a small, small valley and there's some people I've been working with over and over, off and on for like 15 odd years now. And I've had some shitty jobs, but they were mostly pretty brief and not like, they weren't like emotionally traumatizing. They were just boring. But I feel like I worked at Linden Lab for 5 years, like straight out, like my first real job, and that set the bar for me so high.
Hmm.
Like, and I feel like, Christina and I have once in a while, we'll just look at each other and go, if we, when we're feeling like we're failing at everything, we'll be like, if we can just create a job for the people who work here that sets their bar high so that they don't settle for bullshit, then, it'll all have been worth it, because there's really no excuse for accepting shitty jobs. Our skills are in far too much demand.
Yeah, definitely. I mean, the part I think that gets everyone into programming is the creative part of it. You're
Yes.
creating these beautiful abstractions and algorithms and data structures, and that's what I think we should always be striving toward.
Or the impact. I
Yeah.
feel like the DevOps is like this noble attempt to tear down a wall that never should have existed, right? It's like the wall that you throw your code over. This idea that you're done with your job once you have merged your changes to master, right? Like that's terrible. It's not only is it bad for the code and the systems and reliability, it's bad for you because it decouples you from the outcome and the impact of what you've built. And I feel like
Mm-hmm.
all we're trying to do is stitch back this feedback loop so that the people who are experiencing the pain are the ones who are empowered to fix it and who have all the context like fresh in their head, and just like getting that feedback loop going. Like, ops has a well-deserved reputation for masochism, and I'm not the point here is not to invite everyone to like be masochist. The point is that this actually makes things better. That like it shouldn't have to be painful to support these systems, and I definitely believe that.
Yeah, I think the way that you describe DevOps is interesting, because when you talk about it, it's like this thing, in the beginning, Dev and Ops were one, and then there was this schism, and now we're trying to put back kind of the pieces together and rebuild that feedback loop, as you said. But,
Right?
before talking with you, I feel like most of the people I spoke with, it's kind of a new term, right? Like, DevOps is this new thing. We're merging these two separate and distinct things as
It's
Dev
not
and
new at
Ops.
all.
So
It's just getting back to the way it once was, right? When we were all happily like editing source code files live in production
yeah.
as root, the good old days. Yeah. No, like, I mean, you can understand why specialization emerged because of complexity and because it just became impossible, right? And so like the trick, I think that the needle that we have to thread moving forward is to allow for specialization, but not to lose sight of that feedback loop, that really critical, just like heartbeat of shipping code to your users and understanding what you've built.
Yeah. And I think that's a good segue into observability. So, how, first of all, what is observability, and how does it help glue back together those, two
Mm,
sides of software development?
yeah, totally. Observability is basically just, at a high level, it's being able to ask any question of your systems, understand any state that the system's gotten itself into, without having to have prior knowledge of it, without, having seen it break before, and without shipping any new custom code to handle the question that you're trying to ask, because that implies that you could have predicted what question you're going to need to ask, right? Like if you think back to like what the telemetry we've had today, like metrics and logs, right? With logs, you can always find what you have to go look for. And if you don't know to log it, and if you don't know to look for it, well, you're screwed, right? And with metrics, it's like you're just like, there are all these little counters and stuff that are firing as your code is executing. It might fire off, a couple hundred metrics while one request is executing, but none of them are they're not tied together. And because there's no connective tissue, that means you can't ask all these new questions that would, like, oh, okay, this metric spiked. Well, what else did the things that spiked have in common, right? They're just all these things that, like, because you didn't collect the data in the right way, you can't ask those questions. You can't understand these complex states. So observability is the term comes from control theory, which has its roots in mechanical engineering. When we were building Honeycomb, and non-trivial, we've had to build our storage engine and query planner and everything from the ground up to support these data structures. Far more difficult than building the technology was figuring out how to talk about it, because every term in data is so overloaded. Every data tools demo looks exactly the same. They're all
Yeah.
like, and 6 months in, I was still trying to I knew we weren't a monitoring tool, because monitoring is very reactive, right? Like, you define these arbitrary thresholds and then you just monitor the thing. You just check over and over. Is it up? Is it up? Is it up? Right? I knew we weren't that. And it wasn't like till 6 months through that first year that I saw the term observability. I think it was from the Twitter team was named observability. And I looked up the definition, and I just I just had like light bulbs going off in my brain, just like, oh my God, this is what we're trying to do. So the reason we were building this, I'll back up just a little bit. Christine, my co-founder, and I, we both come from Parse, the mobile backend of the service. In Parse, we had about 60,000 mobile apps on our backend when we got acquired by Facebook. And that was around
Wow.
the time that I was coming to the horrified conclusion that we had built a system that was basically undebuggable by some of the best engineers I have ever known, doing all the quote unquote right things. But like a few times a day, like, be like, Disney says their app is down. I'd be like, well, behold my wall full of dashboards. Like, everything's fine. It's all green, right? Because maybe Disney's doing like 4 requests per second and I'm doing
Yeah,
100,000
right.
requests per second. It's never going to show up in my time series aggregates.
Right.
Or, whatever. So it could be an app that's complaining they're down or whatever. So I'd have to go and figure out what was going on. Very brute force manual labor process, because, you've got your top 10 lists and you've got the questions that you defined in advance to monitor. And then if those weren't the problem, you're looking for a needle in a haystack. And you're looking for a needle in a haystack when, okay, so Disney thinks their app is down. Well, it could be something that they did, something that we did, some combination of the two, or because we're using these big like pools of unicorn workers, shared databases. It could be any one of those other 60,000 mobile apps is doing something that caused a starvation of resources on any one of those pools of resources.
Yeah.
So it's just literally impossible to figure out what the fuck is going on. And like, I tried every tool out there, and the first like glimmer of hope that we had was we started feeding some data sets into this tool at Facebook called Scuba, which is aggressively hostile tool. Like, it's not fun to use, but it does one thing really well, which is it lets you break down by dimensions of high cardinality. So if you've got like 60,000 mobile apps, it'll let you break down by that app ID, and then by, whatever else you want. And this was like, I didn't really get why at the time, but this is like, this is a core pillar of, what it means to have observability is high cardinality. Because what if you're looking for a needle in a haystack, what is going to be the most identifying information? It's going to be any unique ID, right? And everything out there that's built on top of metrics, you can't have high cardinality dimensions and tags. Like, you could have maybe 100, and then it's just like you're cut off. Like, you're going to explode the key space, and you can no longer even tag them with that data.
Yeah. So high cardinality, like help me understand.
It's the unique items in a set. So
Yeah.
imagine you have a collection of 100 million users. Your social security number is the highest possible cardinality you can get.
Got
Last
it.
name and first name are very high cardinality. Gender is very low cardinality. So
Mhm.
if you're searching for somebody and you're searching by gender, that's going to not be super useful to
You're
you
going to get a lot of results, and you're
for
not going to
most
be able
data
to filter
sets.
down and drill down.
Exactly. And so this tool at Facebook that like let us break down by these high cardinality dimensions, suddenly we could, and if you think about like all of the questions out there that you as a software engineer want to answer, they're often by chaining together many of these high cardinality. So it's high cardinality and high dimensionality. So it's like
Yeah.
this bug is only tripped when it's on a user using this version of iOS, using this version of the firmware, using this version of the app, using this region, using this language pack, using, like every single one of these is high cardinality. And that's the only way to like zero in and track it down. But once you can do that, it becomes really easy, like really dead simple. And this is what I realized was that, instead of like, the way that we quote unquote debug right now is like we form these castles in our minds and we guess what the answer is, and then we go look for evidence of that answer. Well, instead of, if we had a tool that just let us take one foot after the other and follow the trail of breadcrumbs, so that you don't have to know what the answer is, you don't have to know where you're going to end up. You can just start looking. So for example, I see a spike. What's wrong? Well, I don't know what's wrong, but I can go and break down by endpoint. Which ones are slow? Oh, it looks like all the right endpoints are slow. Is it all of them? No, it's just the ones that talk to this particular backend. Is it all of them? No, it's just the ones to that shard. Or, those two shards. What do they have in common? Well, the primary, so it's just like it's almost like bringing science back into
Yeah.
computer science. And this is why, like, I feel very strongly about things like testing and production. I feel like, all right, I don't know how much you want to expand this rant to, but like,
Keep going.
testing and production is inevitable. It is something that all of us do. We have to do it. It's called reality,
Yeah.
I feel like, TDD was great, most successful like software movement of my lifetime, but it 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 got predictability and repeatability at the sacrifice of everything interesting. Like, you're just like, everything interesting is now a mock. Test like the end at the edge of your laptop. And that means that like everybody should know better than to think that their staging environment is going to resemble production, right? And if instead, if you instead of like writing code until your test pass, if instead you write code while instrumenting with an eye towards how you're going to understand, is this working or not in production? And then if you can, get it in, if you have everything automated so that when you merge to master, it gets out to production in a matter of minutes, and then you have muscle memory. You just go and look. Is it doing what you expected it to do? Does anything else look weird? Like, closing that loop right there, you will catch 80 or 90% of all problems before your users ever even catch a whiff of it. It is weird that we aren't doing this. That's how we used to write code, right? We would write code right there on production, hit save, reload the browser, see what happened, right? That virtuous feedback loop has gotten all broken up and like tossed to the four winds, and we've lost that tight and really grounded in realities form of testing.
Yeah, totally. And a lot of what you're saying really resonates with me because, just to be clear to our audience, SourceGraph is a Honeycomb customer, and we use it for one instance of Sourcegraph, which is the most important instance, sourcegraph.com, but we can't use it for a lot of our on-prem, customer instances because, they don't want to send their data over to the cloud. And the kind of difference in the experience of debugging an issue on sourcegraph.com versus one of those on-prem instances is quite different. When we don't have Honeycomb available, it's like, okay, there's a Prometheus alert that's firing. It indicates that, some endpoint is, taking longer than we expect. Okay, then the question is like, okay, let me kind of pin down that to a specific issue. And that's a fairly big jump to have to make, because then you have to like dig into the logs. You might like try to reproduce it in the UI. You open up Jaeger to try to, capture the trace as it happens. And it's just kind of this song and dance. Whereas I feel like with sourcegraph.com, we can answer a lot of those questions just within Honeycomb first, because we're, like you said, it's providing that high cardinality data set to you, and you can just kind of go in and explore the data instead of having to jump to different tools to
This is an
answer the question.
experience that very few engineers have ever had. And this is why, debugging, this is why we think computers are hard, is fundamentally because we have so little visibility and insight into how they work. And we don't have the tools to even ask pretty big, the experience of after you've figured it out, it's the most obvious thing in the world, right? Those categories of problems should never have been hard. It's just that like you had to almost figure it out from first principles by reasoning about it in your head. And that's insane. We can't do that. We're not good at that. It's so much easier when you just bring it out into the open, where you can just watch it, you can ask simple questions, you can see what's happening, and then you don't have to guess. You don't have to like model the entire caching like ecosystem in your brain just to like make a reasonable guess about what's going to happen next.
Yeah. Now, let me kind of take devil's advocate position here a little bit. And so, earlier you were talking about the importance of high cardinality in observability tools.
Mm-hmm.
What would you say to skeptics who say that, high cardinality is great, but you're never going to have kind of infinite cardinality? And this whole like promise of like granting like, giving someone access to like a data set that represents everything that's happening in production, that's never going to be the case. It's always there's always going to be something that you're going to miss because you haven't instrumented your app to track that particular event before. And so it's you're always going to go back and forth between like, this thing isn't implemented. Yeah.
It's not really about always being able to find exactly what's wrong. It's much more about being able to find out where exactly the problem lives. Right? Like it's not like you might not be able to. So from the perspective of your Honeycomb data set, you probably can't, if there's a firmware bug that's causing, 10% of hosts to blow out. Honeycomb's not going to tell you that, but it's going to tell you exactly which subset is erroring and what they have in common, right? It's like the hardest problem in distributed systems is not debugging the code; it's figuring out where is the code that you need to debug. And this is where it's so interesting, because like we've with like distributed systems recently, like we've taken what used to all live inside the application monolith and we've just blown it up. So now we're hopping the network all over. So you can no longer attach a debugger and just step through your code, right? If you want to follow your code logic, you actually have to like do all this operational stuff and hop from machine to machine. So like, I feel like there is still like, hardware is not yet cheap enough that we can pump the output of like a debugger run of all of our processes into something that's tractable. Like, no, but like what we can do is say, this is the conditions under which the problem happens. That's enough for you operationally to get to a known good state and be stable, right? Resiliency is not about, it's not about making it so that things never fail. It's about making it so that lots of things can fail and your users don't notice, right? Yeah.
How prescriptive are you about, what sort of things your users and customers should track? Obviously I could, in theory, send anything over in the metadata that accompanies like an event. And
well, I would say about a third of the magic and power of observability is in the gathering of data and storing it in the right way. With metrics, like I said, there's maybe 200 different, verbs of data there, but they're all blown up and separate from each other. You can't work backwards. You can't go back from 200 metrics to an event, but you can go from an event to 200 metrics. So it's actually very fundamental to observability that the source of truth are these arbitrarily wide structured data blobs from which you can derive logs or metrics or traces or whatever. And it's important that they be arbitrarily wide because like anything with schemas or indexes or anything is again locking you into, you're saying, I am only ever going to want to know these facts about my system, which is kind of anathema, right? You want to be able to toss in more detail whenever it occurs to you. Oh, this might be interesting. So and you want to gather it up basically one blob per request per hop. So your request enters the system, maybe it hits the API server, that's one blob, and maybe it bounces off to hit the payment service, that's another blob. And when the request enters the service, like we initialize an empty Honeycomb blob, and then we pre-populate it with everything that we know or can infer about the system, the language internals, the parameters that were passed in, like all the basics. And then while it's executing in your service, you can effectively do like a printf, just print any details that you want into it. And what you want to capture is any unique IDs, like anything where you're like, oh yeah, somebody's gonna file a bug someday and I'm gonna want to be able to find it by this, right? Shopping cart ID, etc. Just stuff them all in, and then when the request is ready to exit the service, it just ships that off as one very wide structured blob. And we find that a maturely instrumented service will have usually 300 to 400 dimensions. It'll be 300 to 400 like verbs wide, so to speak. That just seems to be like where they stabilize, and that's way more than you can keep track of in your head. So but that's fine, right? Because, well, like for example with bubble up, if you see a spike and you're like, what's going on here? Well, you just draw a little bubble around it, and then we pre-compute for all of the dimensions both inside the circle and outside the circle, and then we diff them, and then we sort them so that the ones that are different come to the top. So if it's like, oh, this spike, these requests are different in these 5 ways, well, you can just see that as a glance. Like, you don't have to actually like keep a dictionary in your head and refer to them.
Yeah.
There should be very little friction to tossing them in. And people can do this. And I recently found out actually that Amazon follows an internal logging spec that is almost exactly like this.
Interesting.
And has for like a decade. It was really difficult for us to figure that out. I wish they would have just open sourced that so we could have leapfrogged that year. Yeah, but no, it's really important that you gather things up that way, because that allows you to ask all of these novel questions later on that you may not have ever predicted that you might want to ask, or associations that might not have been obvious, right? Because it's all about making it visible and easy for the human user to figure out what's important to them, which means it's about aligning you with your users, right? And that, like, aggregating it around the request means that you'll be able to see exactly what kind of experience your user is having. That's another core pillar of observability, honestly, is shifting away the emphasis from the systems and the infrastructure to the user's experience.
Because in order to kind of gauge what the user experience is, you really have to pull in a kind of a variety of data, right? It's not just a single log line. It's not just a single...
Yeah, it's all about, from the perspective of that request, was it like, we don't actually care if, the cache server was down or if something was down. What we care about is the ability of each request to exit or not, right? Versus like if you're doing traditional monitoring of your infrastructure, all you have is aggregates. You can't ever actually trace that back and figure out what anybody's actual performance was like.
Yeah, that makes sense. Kind of, taking a step back here for a moment, one of the things that I struggle with, and I imagine a lot of listeners also have kind of dealt with in the past, is there's just like a a lot of different tools in kind of the space of observability, monitoring, log aggregation,
Yeah.
that sort of thing. So like, like APM tools like Datadog, New Relay, you got distributed tracers like Lightstib, Zipkin, Jaeger, there's like application level monitoring
Yeah.
tools like Sentry, and then there's the
And
Prometheus.
it's in a
Like,
really confusing state right now. And the reason is because they're all in the process of converging. Like, I
hmm,
think over the next 3, 4, maybe 5 years, you're going to see the collapse of APM monitoring metrics, log aggregation, except the security use case, I think might hang on as its own thing for a while. But like, you can see this already starting to happen in just the acquisitions that they're doing, and the like, Splunk acquired Signal Effects and Omnition, right? And it's partly an artifact of this three pillars myth. There's no such thing as pillars in observability, because those are just
but
data structures. They're just
what is
data
the
types.
three pillars myth?
This is something that all of the big players like to say, is that there are three pillars of observability:
Mm-hmm.
metrics, logs, and traces, which just, they happen to have a metrics product to sell you, a logs product to sell you, and a tracing product to sell you. And not only is this wasteful, it is worse than that, because you should only have to pay to store that data once, not 3 times. And like, if you're paying to store to store it 3 times in these, prematurely optimized formats, then you have to have a human in the middle who's just like sitting there copy pasting from one to the other, right? This is where you've got like people, you'll sit and look at your dashboards. There's a spike, I want to know what's going on. So then you have to turn over to their logging and use a completely different data set to like dive in and figure out what's going on. And if they want to trace it, they have to copy paste an ID over to their tracing thing. Like, that is broken in so many ways. It should just be a visualization by time to trace, and that's it. It should not be a separate product.
Got it. And so, the way Honeycomb looks at these different facets of observability, how do you integrate all that into one application? I mean, do you think it's all going to be one interface, or do you think there's going to be like plugins and
Yeah, I mean, the important thing is that you need to be able to come in at a very high level, like your dashboard view, right? Like, there's a dip, there's a spike, there's something, right? And you need to be able to slice and dice and figure it all the way down to the raw rows, so that you can figure out exactly what is going on. Uh, Observability absolutely depends on having access to raw rows, because if you don't have access to the raw rows, then you can only ask the questions that you happen to aggregate on when you were ingesting the data, right? But if you have those raw rows, if you have the ability to just slice and dice and like cut it up in various ways, and like, you should be able to flip back and forth between tracing, which is just an overview of, a waterfall. You just viewing the events by time instead of viewing by, count. Yeah, they should just be two sides of the same coin. It should feel absolutely, seamless to move back
it's
and
like
forth.
it's like data science in a way. Like it's just another data set that you're trying to explore, and you have kind of your database, and then in various, I guess, like visualization.
Yeah, like, so you might be like slicing and dicing, and then, oh, you find an example of the error. So you want to trace it and see visualize where exactly that time is going. Oh, and then you see, the time is going there. So then you might want to zoom back out and see who else is impacted by this. You might just going in and out of the views like that. So you were saying, yes. Yes, the space is very congested. And in fact, when Christine and I were starting this company 4.5 years ago, we had so many people tell us very condescendingly that there was no room for any, like, it's a solved problem. there's no nothing left to be done, which is kind of true. I think that metrics have reached the end of the road. I do not think there will ever be another better, shinier metrics product built than Datadog and Signal Effects. That horse has been driven into the ground. But I think that what you're seeing right now is companies in those 3 or 4 different, different markets. They're all trying to get technically to where Honeycomb sits right now with our arbitrarily wide structured data blobs faster than we can get to where they sit on their business side.
Yeah. Yeah, that makes sense, and it's definitely far from a solved problem. I mean, like
Oh,
the
no.
the gap between dev and ops is still a difficult one to traverse, and kind
Yeah.
of revisiting that for a bit. I think one of the challenges is that a lot of developers who don't come from an ops background, it's almost like ops can seem a bit intimidating.
Oh yeah.
And
Oh,
for
we've
a tool like,
worked
yeah,
we've
sorry, go
worked hard. We've worked very hard to make people think that we're scary too.
ahead. Yeah, and so I was going to ask for like a tool like Honeycomb. When you go inside a customer, and let's say a customer buys Honeycomb, and they want all their developers, or as many developers as possible, to know that it exists and to use it and understand it because they want to bridge that gap. Do you have like I've talked to a lot of other developer tools creators who sometimes have trouble spreading the word. Like the people who brought you in are gung ho, they love your product, but then the rest of the team is like, that seems like not
Mm.
my job or not my thing, or like that's yet another tool I have to learn. Can you talk a little bit about how you kind of grow awareness inside companies about this amazing tool that?
Yeah. This hasn't actually been something that we have really struggled with too much. And I think part of that is because we, like from the very beginning, we have always seen ourselves not as building for people, individuals, but as building for teams. So you'll notice, like, there's this Slack buttons where if you have a graph and you're like, cool thing, I want to share this with my team, you just push the button, it goes to Slack, and then they see, the preview of the graph, and then they can also click it, which makes them jump into Honeycomb, and then they can see not only, your graph, but like your history.
That's cool.
And I feel like, you know, I feel like this is an area where the entire industry has been, like, we talk about people and culture so much, but we don't really bake that into our products. And I feel like, Christine and I used to talk a lot about how debugging was like following a pathway. Sometimes you go down a wrong fork. You need to be able to go back to when you last knew that you had the plot, right? And similarly, like, each of us who's working on our own little corner of this giant distributed system, we know our own little plot intimately for a while, but we don't but we're responsible for the whole thing, and we don't know jack shit about anyone else's corners, right? And so it's kind of like
So true.
we need to like you need to wear grooves in the system as you use it, so that people who come along after you, or you who comes along after you a few months from now when you've forgotten everything that you ever knew about what you were doing, you need to be able to look at your history and what were you doing, what kinds of questions did you ask, like how did you actually solve a problem. So, like, one use case that we people use a lot is, if I got paged about something, say I get paged about MySQL and it's 2 a.m. and I don't know fuck all about MySQL, but I know that, like, the experts at our company are like Ben and Emily, and I feel like the last time this happened, I think Ben was on call, and it was like, it was like 2 a.m., like Wednesday or Thursday, right? So I can search back. I can just, go back and look. What did Ben ask that involved MySQL? What questions did he ask? What did he post to Slack? What did he think was meaningful? What did he rerun a bunch of times, right? It's like a better version of everyone's bash history file, right? Like, you just want access to like a little snippet of their brain so that you don't have to call them and wake them up. And that collaboration aspect, and collaborating is not just for other people's benefits, like collaborating is for like past you collaborating with future you, like it's the same mechanic there, and I feel like, I for all that we talk about collaboration, it astonishes me that, like, even basic history stuff isn't baked into most tools, which, you know yeah, I don't remember, what
Yeah,
was the
yeah.
question?
No, I mean, I want to dig into that a little bit more because so at SourceGraph we used to have this thing called the ops log, and we still do it. Basically, the idea is anytime you're on call and you have to resolve a
Yeah, but the
production
stuff you
issue.
remember to write down is never going to be the actual stuff that you needed.
Exactly. So it helps to a certain extent because
Yeah,
you can like if you take the time to write stuff down, and if that stuff happens to be the relevant stuff later, it's
exactly.
helpful. But I think one of the shortcomings we've seen in it is that that's not always the case. And can you
Yeah.
talk about how Honeycomb helps address that?
Yeah, I mean, you should not have to, like, consciously decide this is going to be important, because it's always the shit that you do when you're not thinking it's going to be important, or you're just like panicked, you're in a rush, you're not thinking about, doing things, with a record for the future. It really has to be something that just ambiently is captured, the way that you work with the system independent of you deciding, right? Like the way that you describe your behavior is never the same as your actual behavior. And yeah. And I feel like I also just I want to reward curiosity and exploration and people who are having fun with their systems. I feel like it's one of the most unfortunate characteristics of most systems is that the person who knows it the best is the person who's been there the longest, like full stop. And that's we have just decided that this is normal and this is just how it is, but it's not. It's a sign that your tooling sucks because it's a sign that you're not actually using your tools to understand your systems. You're mostly relying on your memory of past outages and your scar tissue, right? And if you were actually relying on your tools, then it should be the case that the person who's the best debugger is the person who spends the most time debugging, or the person who's the most curious. Every team has a couple of people who are like this, right? Who just follow their nose, and the unfortunate thing is that so many of us get it beaten out of us because you pick up the rock and then whoa, like that was a mistake, right? But like if we could not punish people for following their curiosity, but if we could reward it, if they could swiftly and simply just get answers to their questions and then understand their systems a little bit better than they did before, that's just a better world. And I have worked now on two teams where that was the case, where it wasn't the people who have been there the longest were the best debuggers. It's the people who enjoy debugging the most, and that was at, Parse at Facebook and here at Honeycomb. And so like this is one of the many, many ways where I feel like the biggest hurdle that we face in computers is our low standards for ourselves, our expectation that the world is just this crappy and this is just as good as we get to expect,
Yeah.
like on call, like I believe that every engineer who builds 24/7 systems should participate in on-call in some form or another. And I believe that commitment should be met by management in committing to giving you the time to actually fix the thing so that it isn't hell, right? Like if you're getting woken up more than 2 or 3 times a year, it's too much. And we should treat that as like a heart attack, not like diabetes, and like and the reason that these systems are so flaky and so fragile is because we've never understood them. Like we keep shipping new code every day that we do not understand onto these coughed up hairball systems that we've never understood, and we're just like closing our eyes and hitting deploy and crossing our fingers and hoping for best. And like the outcome's not going to be that great. But that is a choice, right? And like, yes, that is the best that is the most visibility that you can expect from monitoring tools. But from observability tools, where you can pinpoint exactly which requests are failing and what's different about them swiftly and correlate it to a change in the system, there's no excuse for this. Like your system should be comprehensible. People should be in the habit of spending time going and looking through the shit they just pushed to prod and understanding it and expecting it to be understandable.
Yeah. It's kind of the idea that like, I have some SQL terminal, and maybe SQL is not the right analogy here because it's a structured. It assumes a schema, but like some sort of query language over a database that contains every single log line, every single like request latency with metadata, every single kind of distributed trace, and that is kind of the way I think about debugging a production issue, like hopping into that and exploring. Is that the like kind of holy grail here?
I think I'm following. Yeah, I think so. Like, yes, just so the holy grail here is to push back that moment of figuring out that there is a problem to wait earlier, right? Instead of getting a Jira task about something that's been broken for months,
Yeah.
and like everybody's forgotten, it should be that you
Okay, so
find these.
it kind of starts with alerting then, like being alerted
So
that there's an issue.
so I think that most alerting systems are you have to set the threshold somewhere that won't like kill you with alerts and
Yeah.
will give you, and therefore you're going to need to go and look at it. You need to go and look at your systems through the lens of your instrumentation and see, is it doing what I expected it to? Does anything else look weird? And your human eyes, if you're interacting with your data, you're going to pull out so many more subtler bugs and problems than would rise to the level of paging someone, right? Which is why we really have to like make it a production practice and an expectation that everyone who's writing code spends time every week with their eyes on production on their code, right? Because otherwise it just you're going to accumulate all these little shitty bugs that are not quite catastrophic enough to wake someone up, but they're still bad, so, but I feel like so like with Honeycomb alerts, the way we've built them in there, we're thinking less of like high level, you're on call, this is a sign that your customers are in pain. Like that's a job for SLOs. But if you're an engineer who's developing on an endpoint, you might want to put a trigger on there because you want to know if anything that seems out of the norm is happening while you're shipping, right? So it's like over a 2 or 3 week period while you're making changes to a particular endpoint, right? You might just put some triggers there just to like shoot you a Slack message during the daytime and let you know if like if I don't know what, just make up some things you think might be a sign of something weird or bad or odd, right? And it's like bringing your systems into like this constant conversation with you, right? But you're in conversation with your code and your users right now, right? As because you're going to write some code, you're going to ship it, it's going to have some unintended consequences, but while you're working on it, you're going to be there, your eyes are going to be on it, you're going to notice some of these things, right?
Yeah, that makes total sense. It's like, I guess part of it would be, you want to get, not necessarily, you don't want to wait until the
You don't
patient
want
is
to
in the emergency room when you got that
exactly.
midnight phone
You want
call.
to exercise and like go for walks and eat right and stuff. You don't want to like wait to have a heart attack before you see the doctor.
Yeah, you want like Apple Watch indicators.
Exactly. The Apple Watch of systems. Exactly. That's perfect.
I like that. Kind of going back to the beginnings of Honeycomb, I'd love to hear about kind of the story of how you met your co-founder Christine, and what was the point at which you both decided, like, hey, let's go build a company called Honeycomb.
Yeah. And first my brain was just kind of like wandering off in the direction of what you were saying earlier about, we as engineers, how we love to build things. We love to see the impact of what we've built. And I feel like this, people who resist being on call for the system, people who don't like the sound of this, are people who have been burned, people who've been burned out. It is so deeply satisfying as an engineer to just watch what you've built work.
Yeah.
I feel like there's just something like intrinsically, sometimes you have to like push people over the hump to get them to try it, but like it's so much better than driving in the dark. All right, so yeah, Christine is amazing. So Christine was at Parse with me. So I was the infrastructure tech lead, and Christine single-handedly built the Parse analytics product. And so she had built this product for our users, built on top of Cassandra, time series database, and she started encountering all these frustrations where our users were wanting to ask questions of their analytics and they couldn't because they had been locked into the questions that they had decided to capture the data for up front, and they couldn't ask new questions. And so Christine would get frustrated and she would fall back to Scuba. So Christine left Facebook a while before I did. She went to the East Coast and stuff. And we didn't really know each other all that well. But then when she was coming back, she was asking me, do you know of anything interesting going on? And I was like, well, we're starting a company. It's totally going to fail, but it might be fun, you know? And bless her heart, like she was all in. We really, all right, I was so sure we were going to fail, and I was fine with it because the reason I was doing this was because I couldn't imagine being an engineer without it. Like the idea of having to live without the tooling that we had built, like my ego couldn't take it. Like I would have been such a less powerful engineer. It just, and so I was like, okay, there's some people, pursuing us with some funding. We'll take it, we'll build it, we'll fail, and then we'll open source it, and I won't have to live without it. And that was really the grand plan from the beginning. And then we just kept not failing by accident. And this is the first year where I'm kind of like, this might be a real thing, which probably means we're now doomed. That's my ops blood talking. No, but Christina's amazing. So like in the beginning, it was 3 of us, and our third co-founder didn't work out pretty quickly. And that's how I got pushed into being CEO, which I did not want to do. I had nightmares about being unemployable for the entire 3.5 years that I was CEO. Christine and I swapped places a little over a year ago, and she is now CEO, and this is much better. It's much better. CEO is the worst job in the world.
Talk to me about some of the pain points of being a DevTools startup CEO.
Some of the pain points for me were, so I've never been one of those kids who's like, I'm going to start a company when I grow up, because I really despise those people. I really don't like the whole Silicon Valley cult of the founder. I find it very off-putting. And when it comes to like the CEO gig, I dislike the I don't know, there's just so much grandiosity about it, and there's so much. I alienated more than a few venture capitalists, which isn't ideal when you're in my position.
Oh no.
It just, I am. So, all right, here's a pro tip. If you're into people or management or whatever, there's a book called The 4 Tendencies by, what's her name? She did the Happiness Project. Gretchen Rubin. Yes. And this, I'm pretty skeptical about almost all personality stuff, but this one's very straightforward. It's like basically what motivates you, living up to internal expectations that you have of yourself or external expectations that people have of you. And there's basically 4 possibilities, right? Either yes, you're motivated by both, no, you're motivated by neither, or you're motivated by living up to other people's expectations, or you really only care about you yourself. And I am the rebel type that rejects. As soon as there is an expectation of me, I do not want to fulfill it. I'm kind of a little shit. And like that personality type, she even calls it out in the book. She's like laughing. She's like, I don't see how any rebel could be a successful CEO. Ha 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 ha. I was just like, fuck you, lady. But there's some real truth. And Christine is the upholder type, where she really gets a lot of joy and meaning out of living up to expectations, both that she herself has and that others have of her. And I feel very grateful and blessed to have a co-founder who does.
Yeah, I mean, what you're saying, I think I have a little bit of that as well.
It's a really illuminating book. I got so much out for my personal relationships, my work relationships, my just understanding of, like, I highly recommend it.
That's cool. I'll check it out.
Which type are you? I think most people just know off the bat.
What were my options again?
Well, are you motivated by other people's expectations of you, or so the types are upholder, where you uphold both; rebel, where you reject both; obliger, where you external expectations; or
definitely
questioner.
Not obliger.
Yeah,
just the word.
Most people are, and that's great. That's why the world works, because most people want to please other people, and that is fantastic.
Yeah. Yeah, I mean, I honestly think the rebel thing is that persona is probably what I identify most with. Like, I was a very difficult child, I would say, and I was one of those kids where, like, if you told me I couldn't do something, then I would go and try to do it. And I think part of me never really grew out of that either. So like any sort of rule that gets imposed, even like
you're automatically like, fuck you, no, this is the last thing I'm gonna do.
Yeah, it's like, why do I need to listen to you? I'm it's a freedom.
Yeah.
Hashtag freedom.
You asked how I got into computers. Literally, it was because I walked past the computer labs. I saw 0 women in there, and I was like, that's where I belong.
That's awesome.
Yes and no.
Well, yeah, not the 0 women being in the computer lab part, but
Yeah.
so one of the things that strikes me about the story of Honeycomb is you mentioned this tool inside Facebook called Scuba that at least partly inspired what Honeycomb is doing, and SourceGraph is a little bit the same. There was this internal tool at Google that I had the chance to use called Code Search
Mhm.
that partly inspired me to want to build something like SourceGraph, and I would love to get your take on first of all, people working inside fantastic developer organizations like that, they're going to see tools that they find useful that are probably found nowhere else in the world.
Mhm.
But at the same time, there's kind of a set of unique challenges that go along with that because, Facebook and Google are Facebook and Google for a reason. There's
Yeah.
really no other place like them. And if you're trying to build a tool that's inspired by stuff that's inside those
Yeah.
organizations, you
Hit or
have to
miss.
adapt it to the broader world, right? So
Yeah.
talk about that.
Yeah, it is interesting. I think Google has kind of made they're a pretty services-oriented organization from what I understand internally, and Facebook is not. Like, they do not have services at all. They,
Interesting.
like, talk to each other and go to meetings to decide that they're gonna do things. It's super weird. Yeah, I think it's interesting because I think that often, people and you can think of so many like Quip came out of Facebook tools, Asana came out of Facebook tools, like, there's a lot of them, and the thing that often trips people up is they come out thinking that the same problems are going to be hard out here as were hard in there, and it is not. Like, you get so used to just like turning on the spigot and whoosh, people show up because they have no choice because they're going to use your tool or they're interested in it. And like, you get out here into little startups and like you turn on the spigot and nothing comes, right? And you really have to work much harder to understand users and court them and look for ways to surprise them with how helpful you can be. And scale is almost never yeah, scale is never the hard part, never. Like I said about Scuba, it's an aggressively hostile to users tool, and they can get away with that. They can just be like, "Fuck you." We're a big ads company. We're not a developer tools company, and so our developer tools are going to suck, and they do, and people use them anyway. What are you going to do? So from day one, like we knew that we had to pay a lot more attention to the user interface. Yeah, I don't know. It's hit or miss. What I do love is I do feel that now, just in the last few years, there's enough there's so many of us that have kind of sprinkled up that you can plumb together a full like CI/CD pipeline that is Facebook quality or Google quality, and you get everything from feature flags and observability and progressive deployments and all this stuff that for forever, like, either you didn't have them or each shop had to like homebrew them, for their custom to their environment. Now you can actually just like pay a couple hundred bucks a month to a handful of tools and you can get some really nice things. So it's interesting if you look at the DORA report, the yearly DevOps research report that gets put out, where they show like they break teams up into like low performers, high performers, elite, etc. And if you look at year over year, for the last couple of years, like the bottom 50% is losing ground. And the top 50%, and especially the elite 20% or so, is they're getting better faster. There's this like total split down the middle. And I think this is because, well, frankly, in tech, if you're standing still, you're moving backwards because complexity is always conspiring to overtake you. And, there's always more and, exceptions. Like, you have to be actively fighting against that in order
Yeah.
to just keep up. But the tools really have like, they really have like begun to make a real difference. And it's the kind of thing where if you get one, then you want another, and then you want another. Like you get feature flags and you want observability, and you start like getting all these things. And with the free time that you buy for yourself, you buy more free time for yourself. And it's just it's like getting on a treadmill of escalating awesomeness once you
Compounds.
start. But if you don't start, your life is getting worse and worse. And it's really, and the thing is, like people often think, oh, well, this is only for great engineers, or I'm not that, this is only for ex Google. It has nothing to do with how good of an engineer you are. Like nothing to do with it. It is, it, these are socio-technical systems, right? The people, the code, the tools you use for deploying and managing that code. And observability is like an important step just so that you can see what the fuck is going on. But it's about the effectiveness of the team, like how high performing the team is. Because I have seen, engineers, you, you know, who leave high performing teams and join low performing teams, and they don't drag the team up to their level, they go down to the team's level, right? And similarly, I've seen people leave low performing teams and join a high performing team, and within 3 to 6 months they're holding their own, right? Like I feel like 80, 90 or more percentage of your velocity and your ability to ship code with confidence has nothing to do with your personal skills. It has everything to do with your team.
Yeah, I mean, that's a fantastic point. And I've never really heard it described in kind of like that fashion, but it really, I think, clicks with me. I mean, there's that kind of old trope about like the 10x engineer in Silicon Valley,
That
and
10x engineer goes and joins a low performing team and they're going to perform right down with them. It's not
yeah,
about the person. And this is why I feel so strongly about managers, about the pendulum, about engineers becoming managers and going back every couple few years. Because I feel like if you want to be a technical leader who has the skill set that it requires to tend to a team and help it raise its level of performance, you can't just focus on one corner. You can't just focus on the people. You can't just focus on the tech. You can't just focus on the tools. Like it takes the ability to reason about the full system, right? Which means that you can't bury your head in either side. Like it takes all everything.
what are some of the things that Honeycomb does internally to kind of foster this culture, this level of
Oh God.
team performance?
I almost feel embarrassed when I talk about our metrics are an order of magnitude better than the most elite team captured in the Dora report.
What metrics are those
The four
specifically?
metrics are the time how often you deploy, time between when you merge and when the code goes live, the uh, how long outages, how long until recovery, and I think it's duration of outages, and I don't remember what the fourth one is,
Yeah,
but something like
we'll
that.
drop
Yeah,
a link in
those
the show
four.
notes. Yeah,
Yeah,
yeah.
and the reason ours are so good is because our system has always been well understood. We have the expectation of building the instrumentation in, looking at the instrumentation when it's live, being able to swiftly, pinpoint and fix problems so it never becomes this hairball. And even when things do go down, it's comprehensible. People can get in there and fix it, and that it's almost like cheating. It's so much easier to work on a system that's never been terrible than it is to dig yourself out of a pit. Like I don't want to like underestimate the amount of work that can be, but like it's not that hard. And we very intentionally did not just go hire all the ex Google, ex Facebook people. We knew we're building a team, a product for everyone, and we wanted, normal people. But the thing is that you become a better engineer so much faster when you're working on a team that ships way more often and gets that feedback loop, quickly, doesn't bury the feedback in ops, but gets it right to you. Like it's almost, I was joking the other day that we're gonna have to like keep hiring new junior engineers because they become seniors too quickly, which is a good problem to have.
Yeah, that's a great problem to have.
Yeah.
Yeah, I want to revisit a kind of thing that you touched on earlier, which is, you're starting to notice more and more kind of gatekeeping in the technology industry, and I think one of the things that I really care about is making technology and software especially accessible to a wider range of
Yeah.
people. People don't have to have that experience of like, oh, there's no women in that computer science lab. Can you talk a little bit about how Honeycomb can kind of like realize that? Do you think that using tools like Honeycomb can actually
Oh,
kind
I
of bridge the
really
gap?
do,
And
because, like, think about how we learn from each other. Like, you wanna look over the shoulder of the senior engineer, and just, like, see how they do what they do. Like, how does their brain even work? Like, what questions do they ask? Which is something that we baked into the product right from day one, thinking about, if you're too bashful to, like, approach someone, you should be able to go and look at how they interact with their systems, just capturing a snippet of their brain. I fundamentally just believe that there are so many things, systems that are broken give people the wrong idea about their own abilities. It's it's not your fault. It's it's the shitty systems. It is so hard right now to get that first job. My little sister just graduated with an engineering degree a couple years ago, and I got to see, like, up close and personal, just how hard it is to get that first job. And, like, once you've gotten that first job, like, the sky's the limit. Like, you got recruiters, like, everybody's pounding down the door, but, like, nobody wants to take the leap. And just, like, what does it take? Like, 3 or 4 months to get them, like, to begin to be productive? Like, it's not that much, and you get loyalty. They're so grateful, and it's just the energy, the fresh eyes. I don't know. I feel like this industry, we really need to figure out how to mentor junior developers remotely, because I feel like the push toward distributed teams is nobody's figured out how to do this. Nobody's figured out how to help
it's a
teach,
brave new world.
you know? And I'm nervous about it too, but, like, we can't keep, like, expecting someone else to pull the cart for us. Like, we all
Yeah.
need to share that load.
I think that one of the bottlenecks to getting more people, especially, in entry level positions into software jobs, is also the time of senior engineers. So like, if you have a limited number of senior engineers, mentorship takes time.
It
It's an
really does.
active job. And oftentimes you can get into the position where if you hire too many junior folks too quickly, the senior
Yeah.
engineers spend all their time mentoring.
And
So I guess where I'm going with all this is, do you think that tooling can help with that? Like with better tools, do they not only help, individual engineers be more productive, but also like, can they facilitate more scalable mentorship?
that's an interesting question, and I'm not sure. What I know that tools can do is do a much better job of rewarding individual effort with results, like, and scaling that out. Like, somebody who's motivated to go poke around and, like, see how Ben, like, solved that MySQL problem. Capturing that in a way so that people have access to, like, how his brain was working when he did that. I have confidence that tools can help with that. There's an interpersonal human element. Uh, people have different learning styles. Some people really rely on the interpersonal, like, emotional connection, and for some people, I think it's actually kind of almost confusing, but, like, almost an obstacle. Um,
Yeah, yeah,
like, I actually find it much easier to sit down and learn 'em by myself, and I find it really confusing. I find it very, well, it's not confusing. It's when people
it's
are
for me it's almost like stressful. Like I have to
it's
be,
really
when I'm with
stressful.
another person, I have to be like on,
Yeah,
in a
yeah.
sense.
I don't do my best thinking while someone else is watching or paying attention, for sure. I don't know. I feel like where tooling can help in general is just, like, with making things asynchronous. And anything that can be made asynchronous can be made scalable. So, but when it comes to things like giving someone real fine-grained personal feedback on their code,
Yeah,
that's just, there's only so much you can, do there.
yeah, yeah. I am kind of the personality type where I like to learn by myself too, and I feel like there are all these kind of, how to put it, they're kind of these like rabbit holes in software not exactly rabbit holes, but like things that are extremely useful, but you don't really acquire unless you. So like an example of this is like Bash scripting,
Yeah.
right? Like when I
There's no
first
class.
yeah, there's no class on that. And then you're like, oh, I know how to write, quick sort. I know all the, data structures. And you get out and you're like, what the heck is
Yeah.
this? Like, I need to like write this in order to,
Right.
make some change on the server. And so like that sort of thing, I feel like there could be a lot better resources, either in the form of tools or tutorials that help people kind of teach themselves through that so that it's not such a black box and they don't view that as an impediment.
I definitely feel like operational skills in general have been a real blind spot as far as our educating. And it's not about the operations, but it is about the ownership. And we can't protect people from the consequences of their code. Like we've got to help them be exposed to it and understand like what happens to their code after they've merged it, right? Like everyone should know what happens between when they merge their code and when the users are using it. And that's just something where like in a classroom setting, you need to have reality to go debug before you can learn those skills, I think, because there are some things you can't just really make into a lesson plan because they rely on the inherent like unpredictability of reality.
So if someone's listening to this and they want to get started with Honeycomb, what should they do?
Go to honeycomb.io. We have a blog that I think has really probably the best roundup of observability resources in the industry. And there's my personal blog at charity.wtf. And you can also follow us on Twitter, honeycomb.io or Mipsy Tipsy.
My guest today has been Charity Majors. Charity, thanks for being on the show.
Thanks so much for having me. This was really fun.
The SourceGraph podcast is a production of SourceGraph, the universal code search engine, which gives you fast and expressive search over the world of code you care about. SourceGraph also provides code navigation abilities like jump to def and references in code review and integrates seamlessly with your code host, whether you're working in open source or on a big, hairy enterprise codebase. To learn more, visit sourcegraph.com. See you next time.